lesson topic for this video is polynomial vocabulary. So we're going to talk about polynomials, obviously. And the first thing I'd like you to do is take a look at this chart. And the first column shows examples of expressions that are polynomials. And the second column shows expressions that are not polynomials. And I want you to just take a couple minutes, maybe even jot down in your notes, what do you notice is true about the first column versus the second column? What's similar? What's different? What do you think makes something maybe not a polynomial? Take a couple minutes. Okay, I hope you really did take a minute and look at these yourself, because I'm not going to explain everything, but I'm going to point out a few things. The only difference between this expression and this expression is the x squared versus the 2 to the x. So that is the difference between a polynomial and not a polynomial in these expressions, is that first term is different. And the situation is when we have a variable as an exponent, that makes something not a polynomial. What else? Well, let's look at these two. The only difference between these two expressions, the only thing, is this negative sign right here. That means that a negative exponent on a variable must not be okay for a polynomial. How about these two? Again, the only thing different is where that radical sign is, that square root. A square root of a number, okay, to be a polynomial. Square root of a variable, not okay. The last row, you'll notice obviously the only thing different really is where that x squared and that x is, and they're in the denominator here, so x's can't be in the denominator. Up here, notice just a single number, that's polynomial. Over here, an x to the 3/4, maybe that's the problem there. Let's take a look at what is and is not a polynomial. Okay, so here are a couple of lists of what a polynomial can have and what it cannot. So what it can have numbers, it can have variables, it can have addition, it can have subtraction, multiplication of terms. All of that is fine. What it cannot have is a fractional exponent, a variable in a square root, a variable in the denominator of a fraction, and a variable as an exponent. So here's an example of both a polynomial and something that is not a polynomial. Here we go. This polynomial here, numbers, variables, the exponents are all numbers. They're not variables. Like over here, we've got a variable as an exponent. That's like our exponential functions. Exponentials are not polynomials. Also, what we were doing in a recent unit, radical functions. Those are not polynomials either, because the radical or the square root had a variable in it. So these are polynomials, and this is not, or this is a polynomial, and this is not. Again, a couple things wrong with this: fractional exponent and a variable as the exponent. Now, one other thing that needs to be pointed out is that it's best to write a polynomial in standard form. Standard form. What that means is that the exponents on the variables, the exponents, decrease from left to right. So we've got an exponent on the variable here, 4. We've got a 2 here, a 5. The exponent here is a 1. Remember that when a variable doesn't have an exponent written in, it's a 1. So we're going to have to rewrite this if we want it in standard form, which we should do. So let's go ahead and do that. Let's start, of course, with our highest value. We're going to decrease. So our highest value is 3x to the 5th. Notice I underlined the positive, the plus in front of that. So we have to pay attention to the sign in front of a term. So we're going to write 3x to the 5th. Then our next term, if we're writing it in standard form, would be this 2x to the 4th because of that x to the 4th. So plus 2x to the 4th. And again, that plus came from the fact that there's no negative out here. Then we're going to have minus 7x squared. minus 7x squared. That negative or minus sign has to come with it. Then plus 9x. And then minus 4. Now, we're going to talk about all the pieces of this polynomial on the next screen. Okay, so here is that expression from the previous screen in standard form. And these things we're going to list right now it's much easier to do once you have it in standard form. So always put your expressions in standard form, and then we will figure out what these answers are. So first of all, number of terms. Remember that terms are separated by plus or minus. So this plus right here separates these two into separate terms. So here's one term, here's another term, here's another term, another, and the last one over here. So 1, 2, 3, 4, 5 terms. There are 5 terms in this polynomial. Okay, degree. Now, the degree and the leading coefficient, are easily found by looking at the very first term, again, when it's listed in standard form. That is 3x to the 5th. So that right there tells us two things. Number one, it tells us that the leading coefficient is 3. Remember that a coefficient is a number in front of a variable. We've talked about that several times before. So that's a number in front of the variable x to the 5th. Because this is in standard form, it's the leading coefficient because it's the coefficient on the very first term. This also tells us what degree the polynomial is in, or is, I should say. And the degree is the highest exponent on a variable in an expression. So this number right here, 5, is our degree. 5th degree, and we sometimes say it's a 5th degree polynomial, right? Okay. Now I want to point out that this 5 and this 5 are not the same 5. Okay. Something is not a 5th degree polynomial if it has 5 terms. That is not true. And I'm going to show you a quick example off to the side. If I had 5x to the 7th minus 4, okay, the degree is 7 and the number of terms is 2. Degree 7, number of terms is 2. So these two numbers don't have to be the same. They just happen to be the same in this expression. Okay. So the number of terms, 1, 2, 3, 4, 5 is this. The degree is the highest exponent. So it's the first exponent if it's written in standard form. The leading coefficient is 3. And the other coefficients in this expression are 2, -7, and 9. Okay, the 2 is the coefficient on our x to the 4th term. The -7 is our coefficient of the x squared term. And remember that negative has to be there because it's a minus right here. And our last coefficient is 9. It's the coefficient of our x term. What about this -4 or -4? Well, that is our constant. And it's our constant because it doesn't have a variable at all. So it's a constant. It doesn't change. Variables change things. That's why we call them variables, because they vary. Okay, so our constant is -4. So if we look at this again, once it's in standard form, leading coefficient is 3. This exponent here is our degree, it's 5th degree. We've got 1, 2, 3, 4, 5 terms. The other coefficients are 2, -7, and 9, and our constant is -4. Okay, so here is a chart to help us practice this information. I'm going to do a couple of these with you. Then I'm going to ask you to try some on your own, and then I'll put the answers in so you can check your work. Okay, so let's just start with the very first one. All right, we have x squared plus 7x minus 3. Is this in standard form? That's the first question you have to ask yourself, because if it's not, you want to do that. It is in standard form. Notice, is this one in standard form? No, it is not. This one is. There's only one term. This one is, because there's only one term. And this one is not yet in standard form. So make sure you rewrite those two in standard form before you come up with your answers. All right, so what degree is this first polynomial? Well, again, since it's in standard form, the degree is told to us by looking at this exponent right here. So this is a degree 2 polynomial, or second degree. The leading coefficient, so be careful here. Remember that there is a coefficient in front of x squared. It is a 1. When it's not written in, a coefficient is 1. Other coefficients in this problem, well, there's a 7, and that's it, right? Positive 7. And our constant is negative 3. In this problem, there's 1, 2, 3 terms. So on this next one, remember, you want to rewrite it first. When you rewrite it, a to the 5th, that term is going to go first. Don't forget that negative has to go with it. So rewrite it and then answer those 5 answers. Okay, here's what you should have got for that one. Take a look, see how you did. Did you say it's degree 5 after you rewrote it? Did you say the leading coefficient is negative 7? The other coefficients are 4, positive 4, and positive 1. Remember, this is a variable, so there's a coefficient here, which, by the way, means there isn't a constant, is not a constant in this expression, so I use this symbol to represent there is none. And there are 3 terms. All right, try the next one, 8m. Okay, how did you do on that one? There is a degree here. It's a first degree polynomial because m does have an exponent of 1. Our leading coefficient is 8 because that is the coefficient on the very first term. There are no other coefficients and there are no constants either. It's just one term. All right, now negative 11. I'm actually going to help you with this one here. Negative 11 is tricky because, well, it's just a number. So is there a degree? Well, there is. Here's the thing. Negative 11 can be rewritten as negative 11 x to the 0. Now, you might not have thought about that, but let's remember our power rules. X to the 0, anything raised to the 0 power is 1. So I can take this x to the 0 and turn it into a 1, and then it's negative 11 times 1, which is negative 11. So this is, and if a polynomial is just a number, the degree is always 0. Now I'm not going to put a slash through this because I'm not saying there's no degree. I'm saying the degree is 0. The leading coefficient, now that's tricky. Now if we look at it like this, it looks like a leading coefficient of negative 11. But since it's actually a constant term, we'll call it a constant and not a leading coefficient. I'm going to say there isn't one here, even though you could make a case for negative 11. There aren't any other coefficients, but there's a constant of negative 11. How many terms? 1. All right, last one. Rewrite that and then restart the video, and then make sure you have it right before you write down your answers for those 5 squares. Okay, so take a look. You should have had x to the 4th plus 2x to the 3rd minus x squared minus x plus 1. Now, fill in these last 5 spots and see how you do. Okay, degree is 4. The leading coefficient is 1 because there's a 1 out here, right? You maybe didn't list both of the negative ones, and that's fine. There's a 2 as a coefficient, and there's a negative 1 on both of these terms, the x squared and the x term. 1 is our constant, and number of terms is 1, 2, 3, 4, 5. Let me know if you have any questions.